Okay, the trig of those angles, 90, 180, 270 and 360. When you look at trig, it looks really easy, but please bear with me and get through to the end and watch these videos multiple times and do lots of questions, because it's somehow, when it gets to the test, it ain't that easy. Okay, so let's think about different angles. So we've got to pretend that all of those terminal rays are the same length. And all I'm doing is changing my theta. And when I look at sine of theta, it's going to be whatever the length of that red line is divided by the black line, if that makes sense. So let's just go, if that's 3, 4 and 5, and that's my theta, sine theta will be 3 over 5. 5 is the length of my terminal ray, and 3 is this red line over here. I'll try and just undo all of those blue things so we get back to that, but that's what I'm thinking of, and all that's happening is that we're changing our theta to see what's happening as we change our theta. Okay. Clearly, if this red length is small, and let's just set our terminal ray to always equal 2. So it's the nice 2, 1, root 3 triangle. So it's always going to be 2, just to make it easy. So if I get a small value for red and I divide it by 2, I'm going to get a even smaller answer. So when theta is small, sine theta has to be small. If I choose a really big theta close to 90, so let's just go 98 degrees, then my red line and my black line are nearly going to be the same, aren't they? So let's just go, theta's not small anymore, it's nearly 90. So sine of nearly 90 must be something very close to 2 divided by 2, because my terminal ray is still 2, that's my hypotenuse, and my red line is very close to 2. So that answer is sort of 0.9 something. It's close to 1, isn't it? Because that's close to 1. That's what we're thinking about with sine, cos, and in these exact values, is that ratio of those side lengths. Let's get to an exact one, sine 0. So here I'm going to draw my terminal ray. I've just about coloured it in. There's my terminal ray. And I want to draw my red vertical line. Now, bearing in mind that black terminal ray is horizontal, how long do you think that red line is? I reckon it's 0 long, because it doesn't go up at all. So remembering that sine theta will be red on black, that red is actually the y component, isn't it? That's why it's red. This red length is going to be my y component, my y projection. How long is my y on the y-axis? And my red is going to be 0, and remember my black, my hypotenuse is always going to be 2. What's 0 divided by 2? 0. So sine 0 is 0. When I'm looking at cos, it's sort of the opposite. Remember, cos isn't, there's my terminal ray, an angle of 0 degrees, so it's horizontal. Cos wasn't the length of my red line, it was the length of my blue line. So cos would be blue over black. Remember, my black's always 2. Now, if my black line is 2 and it's horizontal, how long's my blue line? I reckon it's also 2. What's 2 divided by 2? 1. So, cos 0 is equal to, stop doing that, 1. Tan 0. There's my terminal ray. Tan is the slope of a line. Hey, what's the slope of that thing there? That slope is 0. So tan 0 is 0. Okay, let's get to 90. Hopefully we can get a little bit faster. I'm going to draw my 90. There's my 90. And because it's sine is the y component, so I do that in red. I'm thinking, how long is my red line? So I'm going to go, remember, it's I'm just going to say my black is always 2. So if my black line's 2, how long's my red one? It's 2. What's 2 on 2? So what's sine 90? Or pi on 2? Pi on 2 is 90, isn't it? Yep. It's 1. Cos, here's my 90. Remember, cos wasn't red on black, it's... So my blue is my horizontal line. Well, if that black line's vertical, how long's my blue line? It's 0. So that's 0 on 2, which is 0. So cos 90, 0. Tan 90. Hey, what's the slope of that line? Slope is rise over run. My rise is how long is that? Well, that's my terminal ray. And my run is how far left and right I've gone. Well, I haven't gone anywhere left and right. Hey, does anybody here know how to divide by 0? Correct, you can't. That's undefined. So if you're trying to do tan 90 or tan pi on 2, you will get a math error in your calculator. 180. So here's my 180. My red line is sort of not there, is it? So sine will be O, which is 0, on H, which is 2. So sine 180 is back to 0. Okay. There's my 180 degrees or pi degrees. So cos is blue on black or A on H. So my H is 2. What's my blue? If my black is 2, then my blue is 2. Hang on. Cos is the X component, which is 2, but it's on this side of 0, so it's negative 2. Hey, what's negative 2 divided by 2? So what's cos 180? Negative 1. Tan 180. That's an easy one. There's my 180. That slope is 0. 270. Here's my 270 degrees. Vertical line. Sine is the length of my red line or my y component. Sine is the y component. So that will be, whoops, hey, y is negative down there. So it's going to be negative 2 on 2. So what's sine 270? Negative 1. Cos 270. Cos is this length of the horizontal line, which is 0 on 2. So what's cos 270? 0. tan 270. Hey, that's a vertical line, that is. You can see how with a little bit of understanding you can whip through these pretty quickly, but please at the beginning take your time and think about what's going on. At the beginning there we really had to put some thought into how this works. This drawing here is really important when you come to graphing functions, and that's going to be another video of why does a sine graph look like that. So spend the time now to work out what these projections are or these components are and how they work. Get to it.